Now let's go through some examples of simplifying fractions by combining them together using addition and subtraction. In the first example, we have x plus 1 over x. Now this looks fairly simple, but sometimes we will want to have an answer that isn't just part of a fraction, but the whole thing is a fraction. Remember that when we're adding a fraction to another fraction, we need to have a common denominator. Now I know that this x looks like it doesn't have a denominator, but really when we write something without it looking like it has a denominator, we have to understand that there's really a 1 in the denominator. So remember that when we are adding fractions together, we need to look for a common denominator between the two or more denominators that are present. We can only change denominators by multiplying by something. So the only denominator that we'll be able to have that's common is going to be 1 times x. I'm going to abbreviate common denominator by CD and more specifically LCD for the least common denominator. We just decided that that should be x. Now what we have to do is we have to get this x over 1 to look like an equivalent fraction with a denominator of x. That's going to be done by multiplying it by a fancy version of 1. What do we need to multiply 1 by in order to make it look like x? Well, that's just going to be simply x. If I do that in the denominator, I also have to do it in the numerator, otherwise I'm changing the expression. Now our second fraction here already has the least common denominator, so we don't need to do anything to it. We're just going to leave it as 1 over x. Now what we want to do is rewrite this fraction here, x over 1, as our new fraction with the common denominator. Remember, when we are multiplying fractions together, we will multiply across the numerators and then multiply across the denominators. So this is going to look like x times x, which is x to the second, over 1 times x, which is x. The second fraction here, 1 over x, will just stay as 1 over x. And now that we have achieved the goal of getting a common denominator between these two fractions, now we can add them together into a single fraction by adding their numerators, x squared and 1, and then keeping their denominator as the LCD, or the common denominator that we found, which was x. So what we had was x plus 1 over x, and that is the same as x squared plus 1 all divided by x, if we were to write that in an equivalent fraction. In example 2, we have 1 over x plus 1 minus 2 over 2x minus 1. Again, notice that we have a fraction minus another fraction. In order to combine these together, we need to get a common denominator. I always like to look for the least common denominator, although you can always multiply the individual denominators together to get a denominator that is common. In this case, there's no way to make 2x minus 1 look like x plus 1 by multiplying, and there's no way to make x plus 1 look like 2x minus 1 by multiplying. So the LCD, or the least common denominator, is just going to be the product of the two individual denominators. So now we need to work with each individual fraction and convert the denominator into the LCD, or the common denominator. So our first fraction of 1 over x plus 1, we're going to need to multiply the denominator by 2x minus 1, so that when we multiply these two together, we will get the LCD. We can do that as long as we do it in the numerator. Now here my top and bottom that I'm multiplying by has two pieces to it, so I'm going to want to make sure that I put this in parentheses. And I might even want to stick the original denominator in parentheses as well. Now my second fraction here, I am going to also need to convert this denominator to look like the LCD. So I keep a minus. The original fraction was 2 over 2x minus 1. And I'm going to need to multiply this one by x plus 1 in the denominator over x plus 1 in the numerator, or under rather. Okay, now it looks like when we multiply these two sets of two fractions together, they will end up with the LCD, but we do need to determine what the numerators are going to be. Remember that when you multiply fractions, you just multiply across the top and across the bottom. So our first set of two fractions multiplied here, the numerator is going to be 1 times 2x minus 1. That's just 2x minus 1. In the denominator, I'm just going to leave that as a nice and factored x plus 1 times 2x minus 1. There's no reason for us to FOIL or multiply or distribute this out. It is very happy in its factored form. We keep the minus, and then when we multiply across the numerators in our second set here, we need to make sure that we keep parentheses around the x plus 1 times 2, and then in our denominator here, it looks like it's going to be different, but it's just written in the opposite order. Now that we have a common denominator, we can just combine these fractions together by subtracting their numerators and then leaving the denominator as the common denominator. So in the numerator, we will have 2x minus 1 from the first fraction, then minus. Then from the second fraction, we've got 2 parentheses x plus 1. In the denominator of our new fraction, we're going to have the common denominator. Now again, I know these look different here, but we can multiply things in any order as that we want. It's called the commutative property. So I'm just going to leave this as x plus 1 parentheses times 2x minus 1. The last thing you should do is see if you can simplify in the numerator. Try to, in your mind, think about distributing this minus and even this 2 here into the parentheses. If you did that, you would get some like terms that you might be able to cancel out with the 2x and the negative 1 in the first part of the fraction. So if we distribute the negative and the 2 into the set of parentheses here, what we will get is minus 2x and then minus 2. We didn't do anything with the denominator, so we're just going to leave that exactly the same. Now what we have here is 2x minus 2x. We're adding 2x and then we're subtracting 2x. And addition and subtraction are opposites, so those will cancel out. Then we have minus 1, minus 2. Well, all together, we're going to have minus 3 or negative 3. So in our numerator, that just simplifies to negative 3. In our denominator, again, don't ever try to distribute or FOIL or multiply out the denominator if it's already factored. It wants to be factored. It is in its best form that way. And so here is our most simplified version of subtracting those two fractions. In example 3, we have 3x over x squared minus 9 plus 5 over x plus 3. And we again want to simplify this by combining it into a single fraction. Now, sometimes if you multiply the individual denominators together, you will definitely get a common denominator, but it won't be the least common denominator. And when you don't get the least common denominator, your end result will need to be simplified a little more than if you were to just stop and think smartly in the beginning in order to get the actual least common denominator. The way to do that in expressions that have a polynomial in the bottom is to by completely factoring any denominators that you see. So we can factor the first denominator here into a nice product of x plus 3 times x minus 3 because it is a difference of two squares. So what we can do is, without even finding the LCD first, we can just write this first fraction as 3x over x plus 3 times x minus 3, and then plus the second fraction of 5 over x plus 3. Now the reason that this is really nice is because now you can see that the second denominator is actually already present in part of the first denominator. So the least common denominator is just going to be the product of x plus 3 times x minus 3, because we can make the second denominator look like the first denominator by multiplying by x minus 3. So again, the LCD here is going to be x plus 3 times x minus 3, or x squared minus 9 if you prefer. So to combine these together, I'm just going to leave the first fraction alone. And then what we will do is convert the second fraction into the LCD by multiplying by x minus 3 in the bottom and x minus 3 in the top. Again, just make sure that you have parentheses around anything with more than one term that might be multiplied together. Now our first fraction here, I'm just going to again leave that as 3x over x plus 3 times x minus 3. Then our second fraction, again, we're going to multiply across the top and multiply across the bottom. In the top, we will have 5 parentheses x minus 3. And in the bottom, we will have parentheses x plus 3 times x minus 3. Now that they have the common denominator, we can add them together by adding their numerators. We will get 3x plus 5 times x minus 3. And then we keep the common denominator. So we can write that as x plus 3 times x minus 3, or if you prefer, you can write that as x squared minus 9. Now remember, the last thing to do is to see if the numerator can be simplified further. Normally that means distributing anything in parentheses and trying to see if you can combine any like terms together. So in this case, if we were to distribute this 5 into the x and the minus 3, we will be able to combine like terms with the 3x. When we do that, we will get 3x plus 5x minus 15. Again, that is all over that same denominator, x plus 3 times x minus 3. Now we see that we have 3x plus 5x, and we can combine those together into 8x. The 15 doesn't have anything to combine it with, so we will just leave that as 8x minus 15. And again, in the denominator, if you prefer, you can write that as x squared minus 9, or you can leave it as x plus 3 times x minus 3. Now the very last thing to do in general is see if your numerator could be factored, because maybe you could cancel what's up top with something in the bottom. It doesn't look like the 8x minus 15 can be factored further because we have x to the first, which can't be factored any further, and 8 and 15 don't have any factors in common. In example 4, we have 3 fractions in this expression that we're going to mush together into one fraction. We have 1 over 2x squared minus 1 over 4x plus 3 over x plus 2. Now we need to get a least common denominator amongst 3 things. The idea is the same as if you just have 2 fractions though. It can be helpful if you look at 2 fractions at a time and then throw in the third one after you figure out what the LCD is for the first 2. So here we have 2x squared and 4x. Now I can make the 2 look like the 4 by multiplying by 2. So that means that 4 is probably going to be in the least common denominator because we need the 4 in there, and we can convert this 2 into a 4 by multiplying. So I'm just going to note that. Then this x squared and the x, I can't make x squared look like x, but I can make x look like x squared by multiplying by x. So our LCD is going to need to have an x squared in it. Now this is in fact the least common denominator of the first 2 fractions. If we look at our third fraction, x plus 2, this is a completely different kind of thing. This isn't a power of x that we could maybe, multiply by another x in order to make it look like another power of x. We've got x plus 2, which is different. So in order to include that in our LCD, we're going to need to multiply our 4x squared by x plus 2. Now here is another example where the LCD is not the product of all of the individual denominators. If we were to multiply the 2x squared and the 4x and the x plus 2 together, we would end up with 8x cubed. And that's kind of overkill for our LCD. So again, if you think a little smartly first, it can help you save some time when you won't need to simplify later. Now that we've found our LCD, we need to think about how we will get the LCD in each of our 3 fractions. So the 1 over 2x squared, we have to think about what we will multiply 2x squared by in order to have the denominator, or to make it look like 4x squared times x plus 2. Well, we certainly need to multiply by a 2 in order to get the 4. The x squared is already present in our original denominator, but we will need an x plus 2. Again, if we do that in the bottom, we also have to do that up top. Our second fraction here, 1 over 4x, it already has the 4 present in its denominator. We need to make this x look like an x squared. So we're going to need to multiply by an x in the denominator, and then we also need an x plus 2. If we do that in the bottom, again, we also have to do that in the top. Our last fraction, 3 over x plus 2, what that one is missing from the LCD is the entirety of 4x squared. So we're going to need to multiply this by 4x squared in the bottom and also in the top. Okay, I'm just going to stick parentheses around that x plus 2 to make sure that we remember that the whole thing is multiplied by the 4x squared. I'm going to multiply these individual fractions out, but you could do this in one go if you want by just combining all of the numerators together and then leaving the common denominator. So we multiply the first fractions together. Again, we'll multiply in the numerators. So this will just give us 2 times parentheses x plus 2 all over 2x squared. Oh, not 2x squared. We can probably do 2 times 2 there, so it'll be 4x squared times x plus 2. Again, I want to leave this nice and factored. I don't want to waste my time distributing this 4x squared into the parentheses. It really will not be helpful. In the second part here, if we combine these fractions together, we will multiply across the numerators. That will give us 1 times x plus 2. And then we will also multiply across the denominators, which will give us 4x x plus 2. 4x times x gives us 4x squared, and then we have times x plus 2, which is our LCD, which means we did a good job. Then lastly, in this last group here, we have 3 times 4x squared up in the numerator. That will give us 12x squared. And then in the denominator, even though these are written in the opposite order, x plus 2 times 4x squared, we can just put those in the way that the other fractions are in. So 4x squared times x plus 2. Now lastly, we do want to combine these together into a single fraction because that's our goal. This will be one big fraction, with the denominator being the least common denominator. So 4x squared times x plus 2. Then we'll just put all of our numerators together with the appropriate plus or minus between them. So we'll have 2 times x plus 2 minus x times x plus 2 plus 12x squared. The last thing you want to do is see if you can simplify the numerator at all. And in this case, we can if we just distribute some things across the parentheses and then combine some like terms together. So the first thing I would do is distribute this 2 into the parentheses. So that's going to give us 2x plus 4. Then we have minus x times x plus 2. I'm going to distribute the minus and the x into the set of parentheses at the same time. So that's going to give us minus x squared minus 2x. Then we have plus 12x squared, which is by itself, so there's nothing to simplify there. Now on the bottom, we have 4x squared times x plus 2, and I'm purposely writing this factored still. I'm not distributing the 4x squared because it's never going to help us to do that, so just leave your denominator nice and factored if it's already like that. In the numerator, we have some like terms that will cancel out. We've got 2x minus 2x. Then we have negative x squared plus 12x squared, which can simplify into positive 11x squared. That 4, there's no numbers to combine that with, so that one will just stay as plus 4. Now the very last thing to do is to check and see if maybe your numerator could be factored. The 11 and the 4 don't have any numbers in common, and the x squared, there's no x squared with the 4, so there's no GCF to take out either. This is a sum, one thing squared, I don't know, nothing to factor out in the top. So here is our fully simplified form. In this example, we have what is called a complex fraction. Complex fractions are fractions that have a fraction within a fraction. So you see here we have a big fraction with this fraction bar, and then in the numerator of that big fraction, we've got another fraction. This is not ideal. However, this is the result, what you see in front of you is the result of taking what is called the derivative of a certain function. We will be doing that a lot, and wanting to work with derivatives will kind of be hard if we don't know how to simplify things. This is kind of unmanageable to work with, so we'd like to make it more manageable to work with. What I would suggest doing first is looking at the numerator and just consider simplifying this first. The way you could simplify this is to combine the fractions together. Now, I know you might be thinking this first thing doesn't look like a fraction, even though this second thing is. But really, anything that doesn't have a denominator, we can think of as having a denominator of 1. We just don't write it. So if we're going to combine these together, we need a common denominator. That common denominator is just going to be what's in the denominator of this second fraction here, which is 2 radical x plus 1. So we're going to take the first part here, this just radical x plus 1, and we want to convert it so the denominator is 2 radical x plus 1. Remember, we can do that by just multiplying the denominator by 2 radical x plus 1, but then we also have to do that in the numerator. Then in the second part here, we're just going to leave that as x over 2 radical x plus 1, since it already has the denominator that we're looking for. Now let's just continue focusing on simplifying this. So this first group here, in the denominator, we're going to get the denominator we were looking for, 2 radical x plus 1. When we multiply the numerators, we've got the square root of x plus 1 times the square root of x plus 1. When we multiply a square root by itself, we just get what's underneath the radical. We do still have this 2 multiplied by everything, so I need to do 2 parentheses x plus 1. Then we are still subtracting x over 2 radical x plus 1. Now you might be tempted here to cancel out the 2's. But remember that the reason that we were doing this was to get this 2 in the denominator here, so we can then combine these two fractions together. So when we combine these, they're going to have our LCD of 2 radical x plus 1 in the denominator. Then we will just simply subtract their numerators. So here we'll have 2 times x plus 1 minus x. We can simplify this further. If you think about distributing this 2 into the set of parentheses here, we will be able to access this x and then combine it maybe with that x to the first there. So doing that, we will get 2x plus 2, then minus x, and that's all over 2 radical x plus 1. Now we have 2x minus x. So one last step here is to just combine those together to give us positive 1x. Positive 1x plus 2 over 2 radical x plus 1. Now this is what is in that numerator that we started with. This is what is highlighted in blue over here. So let's step back and look at our original problem and just replace that numerator with the thing that we simplified it with. X plus 2 over 2 radical x plus 1. Then I'm going to make this fraction bar here bigger, just so that I can kind of see that, hey, this is the numerator, and then down here will be the denominator of x plus 1. Now this is still a complex fraction, because we have a fraction still within another fraction. But here we are dividing by a fraction, right? We've got a fraction divided by something. Now, when we are dividing a fraction by something, what we do is we multiply by the flip of the denominator fraction. Now, if you're thinking that denominator here, this one, doesn't look like a fraction, remember that we can just put it over 1, and then it will become more, have the form of more of a fraction. So then what we do is we leave the numerator the same, and we multiply by, instead of divide, this changes to multiply, and we flip the denominator, or we take the reciprocal. So we're going to flip the top and bottom of x plus 1 over 1. So that'll become 1 over x plus 1. Now that's looking better because this is no longer a complex fraction. We do, though, need to multiply these together to get a single fraction. So we'll multiply across the top and across the bottom. X plus 2 times 1 is just x plus 2. And the bottom here, we have 2 radical x plus 1 times x plus 1. This is nicer for sure, but there is still one more thing we can do, because down in the denominator we have a thing, x plus 1 to a power, radical, or 1/2. And then we have another thing, the same thing actually, x plus 1 to another power, to the first. When we have the same base and we are multiplying them together, raised to different powers, remember that we add the exponents. So this is the same as x plus 1 to the 1/2, with the 2 there too, times x plus 1 to the first. If we add the exponents together, we will get x plus 1 to the 1 plus 1 half. In fraction form, that is 3 halves. So this can be one last step to simplify x plus 2 in the numerator, and then 2 times x plus 1 to the 3 halves in the denominator. Now just take a second to look back at where we started and where we ended. I think we would all prefer to work with this form of this expression here if we were to use this to, I don't know, say something about a situation. So it is important for us to be able to simplify these things. It's also really satisfying.